Hi, in this video, I will be demonstrating how to estimate the parameters of a simple linear regression if the raw data is given. The regression equation, which can be estimated using the least squares method, gives the average value of the response variable y as a linear function of the predictor variable x. Before we start the demonstration, let's first define the parameters that we will estimate. Given the samples of x and y, the least squares estimates of the parameters a and b in the regression line y hat is equal to a plus b times x are obtained from the formula b is equal to n times the summation of x times y minus the product of the summation of x and the summation of y all over n times the summation of x squared minus the square of the summation of x. And a is equal to the sample mean of y minus b times the sample mean of x. If we want to formulate a regression line given a set of bivariate data, you may follow the following steps. First, identify the independent and dependent variables. Second, create a table to solve the needed information. And third, write the regression equation in mathematical form. To illustrate this, let's consider example 6.3. A researcher wants to predict the weight in grams of his rats using its height in centimeters. The following data were gathered from 6 rats available in his laboratory. Formulate the regression model using the data. We first identify the independent and dependent variables. Our independent variable is the variable we use to predict the dependent variable. In this case, the researcher wants to use the height of the rats to predict its weight. Therefore, the independent variable is the height in centimeters, whereas the dependent variable is the weight in grams. Next, we create this table and fill in the cells to compute the necessary components of our formula to be used later. So, x squared is 12 squared, which is equal to 144. So, 10 squared is equal to 100. 14 squared is equal to 196. 11 squared is equal to 121. 12 squared is equal to 144. And 9 squared is equal to 81. 18 squared is equal to 324. 17 squared is equal to 289. 23 squared is equal to 529. 19 squared is equal to 361. 20 squared is equal to 400. And 15 squared is equal to 225. 12 times 18 is equal to 216. 10 times 17 is equal to 170. 14 times 23 is equal to 322. 11 times 19 is equal to 209. 12 times 20 is equal to 240. And 9 times 15 is equal to 135. Then, we identify the value of n, which is equal to 6 because we have 6 pairs of data. Next, we compute the sample mean using the formula summation of x over n, which is equal to 12 plus 10 plus 14 plus 11 plus 12 plus 9, that is equal to 68. That's the summation of x divided by 6, which is approximately equal to 11.33. Next, we calculate the sample mean of y using the formula the summation of y divided by n. So the summation of y is 18 plus 17 plus 23 plus 19 plus 20 plus 15, and that is equal to 112 divided by n, which is equal to 6, and this is about 18.67. The summation of x squared is equal to 144 plus 100 plus 196 plus 121 plus 144 plus 81, and that is 786. The summation of y squared is equal to 324 plus 289 plus 529 plus 361 plus 400 plus 225, which is equal to 2,128. And the summation of x times y, that is equal to 216 plus 170 plus 322 plus 209 plus 240 plus 135, and that is equal to 1,292. Now, we have all the necessary information that we need to compute b and a, so we will use the formula. Let's start with b. So b is equal to n, which is equal to 6 times the summation of x times y, which is equal to 1,292, minus the summation of x, which is equal to 68, times the summation of y, which is equal to 112, all over n, which is 6, times the summation of x squared, that's 786, minus the summation of x, then squared. So the summation of x is equal to 68 and squared. Performing this operation, we will get the result. And this is about 1.48. And for a, we use the formula sample mean, which is equal to 18.67 minus b, which is about 1.48, times the sample mean of x, which is about 11.33. And performing this operation, we will have a value of 1.90 approximately. And therefore, the regression equation is given by y hat is equal to 1.90, which is our a, plus 1.48, which is our b, times x. In other words, our y hat is our dependent variable, which is the weight, that is weight hat is equal to 1.90 plus 1.48 times the height. Based on the given equation, if the height is equal to 0, height is equal to 0, our weight on average will be 1.48. So we replace the value of height to 0. And this is about 1.90. This means that if the height of the rat is 0, its expected weight is 1.90 on average. However, this does not make sense because there is no such rat in existence that has a height of 0. Moreover, for every 1 centimeter increase in the rat's height, weight will increase by 1.48 grams on average. To illustrate this, suppose we want to predict the weight of the rat if its height is 10 centimeters. So, height is equal to 10 centimeters. Using the regression equation, we calculate the expected weight of our rat, and that is weight hat is equal to 1.90 plus 1.48 times 10, and that is about 16.7 grams. Hence, on average, the weight will be 16.7 grams if the height is 10 centimeters. Suppose further that we want to predict the weight of the rat if its height is 11 centimeters. Height is 11 centimeters. Using the regression equation, we calculate the expected weight of the rat. That is, weight hat is equal to 1.90 plus 1.48 times 11. This is about 18.18 grams. Hence, on average, the weight will be 18.18 grams. Notice that as we increase the height of the rat by 1 centimeter, the weight will increase by 1.48 grams, which explains our interpretation earlier, which is for every 1 centimeter increase in the rat's height, weight will increase by 1.48 grams on average. Let's consider example 6.4 as our next example. Formulate the regression model using the data below, where X represents the number of absences of a student and Y represents his or her grades. So in this scenario, we want to predict the grades of the student using the number of absent he or she makes in a school year. Clearly, our X here, which represents the number of absences, is our independent variable, whereas our Y, which is represented by the grades, is our dependent variable. Next, we generate this table and fill in the entries of the cells for the next step. That is 2 squared is equal to 4. 1 squared is equal to 1. 7 squared is equal to 49. 3 squared is equal to 9. 5 squared is equal to 25. And 0 squared is equal to 0. Next, 76 squared is equal to 5,776. 96 squared is equal to 9,216. 65 squared is equal to 4,225. 79 squared is equal to 6,241. 71 squared is equal to 5,041. And 88 squared is equal to 7,744. Next, 2 times 76 is equal to 152. 1 times 96 is equal to 96. 7 times 65 is equal to 455. 3 times 79 is equal to 237. 5 times 71 is equal to 355. And 0 times 88 is equal to 0. Then, we identify the value of n, which is 6, compute the sample mean of x using the formula the summation of x over n, which is equal to 2 plus 1 plus 7 plus 3 plus 5 plus 0, which is equal to 18 divided by n, which is 6, and that is equal to 3. Next, calculate the sample mean of y, which is equal to the summation of y over n. And the summation of y is equal to 76 plus 96 plus 65 plus 79 plus 71 plus 88, which is equal to 475 divided by n, which is equal to 6, performing the operation, and we get the sample mean, which is about 79.17. Next, we identify the summation of x squared, which is equal to 4 plus 1 plus 49 plus 9 plus 25 plus 0. That is equal to 88. Next, we compute the summation of y squared, which is equal to 5,776 plus 9,216 plus 4,225 plus 6,241 plus 5,041 plus 7,744, which is equal to 38,243. And finally, let's compute the summation of x times y, which is equal to 152 plus 96 plus 455 plus 237 plus 355 plus 0, which is equal to 1,295. Next, we compute the value of b using the formula n times the summation of x, y minus the summation of x times the summation of y all over n times the summation of x squared minus the summation of x squared. So this is equal to n, that is 6. Summation of xy is 1,295 minus the summation of x, which is equal to 18, times the summation of y, which is equal to 475, all over n, which is 6, times the summation of x squared, which is 88, minus the summation of x, which is 18 squared. Performing this operation, we get the result, which is about negative 3.82. And for A, the formula is the sample mean of y minus b times the sample mean of x. This is equal to 79.17 minus negative 3.82 times the sample mean of x, which is equal to 3, which is about 90.64. Therefore, the regression equation is given by grade hot is equal to 90.64 minus 3.82 times the number of absences. Based on this equation, for every time the student is absent, we may expect a decrease in his or her grades by about 3.82 points. That is because the sign of the parameter is negative. Moreover, if the student is present for the entire school year, which means the number of absences is 0, his or her grades will be expected to be 90.64 on average. We can use this equation to predict the grade of the students based on the number of absences he or she commits in a school year. For example, if the student was absent 3 times, using the regression equation, we can estimate his or her grade, and that is 90.64 minus 3.82 times 3, which is 79.18. And there you have it. That's how we formulate the regression model. That's how we interpret the regression equation. That is how we use the regression equation to predict the value of our dependent variable using our independent variable. I hope you learned something and have a good day.